taking a ride in a computerized flight simulator. At the controls, 2 pilot safety inspectors from the Federal Aviation Administration. This is what it's like landing an airliner through a thunderstorm's downburst.
You want to ride through that, cowboy?
We made it, but just barely. On our second try, we weren't so lucky. Wind shear's been around, well, as long as there's been weather, but it wasn't discovered until we started trying to fly through it. See, an airplane can only fly with the action of the air passing over and under the wing. When the wind shear abruptly changes the speed and direction of that air, it can cause havoc on the plane's ability to fly. Dangerous wind shear at ground levels is the result of a sudden rush of air crashing directly into the ground. It's so strong a downdraft, it's called a downburst. The violence of a downburst is sometimes so strong, the damage it does can look like a tornado's. In fact, many people swear they were hit by a tornado when it was really a downburst they had experienced. But from the air, the difference is easier to distinguish. These pictures by Theodore Fujita of the University of Chicago show typical downburst damage patterns, what Fujita calls a starburst pattern. Tornadoes create more spiral trails. The wind that flattened these trees seems to have come from nowhere. In reality, it came from directly overhead. When the downburst hits the ground, it spreads out in all directions, like spilled water hitting a table, and that's where the wind shear comes in. As an airplane enters the downburst at low levels, say when it's landing, it first hits strong headwinds. That increases its airspeed, and as a result, its lift. The pilot points the nose down to compensate. Then the plane crosses this line and encounters a tailwind. That decreases the speed of the air across the wing, the plane loses lift and begins to fall. If all this comes as a surprise to the pilot, the likely result is a crash. Dr. Kelvin Drogemeyer is studying downburst. He's created graphic downburst simulations on a supercomputer.
So as the rain falls, what you're seeing here, the blues and the greens and the reds, are the cold air. And as the air cools, it falls toward the ground and it spreads out in this extremely thin layer along the ground. The depth of this layer is only, say, on the order of a few hundred meters deep. And that's what makes the microburst particularly dangerous for aircraft, because it's not until they get close enough to the ground, close to landing, that they actually encounter that shear layer.
What would be the most dangerous spot at any one time during the whole loop for a plane to be?
Probably,
is it when it's on its farthest reach there?
Well, actually, in terms of the most dangerous place would probably be right under here, because that's where the strongest downdraft is.
And that's almost straight down on top of them.
Right. And in fact, as the plane is flying through here, not only is it encountering a strong downdraft, but it's also encountering a strong tailwind. So if it's flying something on a trajectory like this, it's in a downdraft, it's also in a tailwind, and the lift of an aircraft goes as a velocity squared. So when there's a small change of velocity, it gets amplified by itself again, which really creates a loss in lift. And when the pilot is going through that, he has to take very drastic action to try and correct it.
Since the risk of wind shear is greatest near the ground, the FAA now recommends the pilot hit the throttle and try to fly up and away from the wind shear and the ground as quickly as possible. Airlines and the FAA are training pilots to escape wind shear.
Wind shear, max power.
But pilots must recognize wind shear when they encounter it in order to take corrective action.
Many of us have gotten into situations where we'd be, for instance, shooting an approach that's rough, it's turbulent. As passengers, we've all ridden in aircraft where the approach was rather rough and that sort of thing. But I think one of the things there is recognition of just how rough is acceptable and how far out of tolerances one would allow one to get. And I think we're judging nowadays that not very far. We try to get out of those situations. First of all, not get into them in the first place, and try to get out of them if we find ourselves there.
If a pilot can't get the plane out of this situation, this can be the result. This L-1011 crashed in Dallas in 1985. 134 aboard the plane died, victims of wind shear. 2 major crashes in 1984 were also caused by wind shear. As the death toll rises, it becomes clear. What's needed is more pilot training and more scientific research into forecasting wind shears. Those research efforts and more in Part 5. For the Weather Channel, I'm Dennis Smith.